So now let me keep it in equation number this. So this is already sigma of equal to 1 to n number of particles, and F is vector which is applied force. If you want to use it here, it's applied force, and this will be equal to sigma of k is equal to 1 to small n del r I del k. This one, and if I keep it in this, let me take that integral value this side, and we can write I is equal to 1 to capital N, k is equal to 1 to small n, and it will be f into E R I by qk and del qk. Let me keep bracket here to here, or if I want to sell, then let me replace it. Note this one. I will keep I part for particle 1 to capital N I will keep here, and if you are interchanging all these things, it won't affect, because integration value, what does it showing? It is telling that k is changing 1 to n. So if I keep it here, wherever, it is going to show same thing only. So that means is k is changing 1 to n. So where is k? K is the k here. So dou q means this value is changing 1 to n. If this value is changing 1 to n. So if you are changing interchanging value, nothing will happen. Same thing it is going to show. So no need to worry about that. Now let me keep it bracket here. It will be k is equal to 1 to n, or we got equation. Now let me replace it one term, that is qk, and this will be qk. So I is equal to 1 to n, or del r with n. So in this equation, now what did I do? I converted it into this form to, in this one, qk means generalized coordinate, but thing is that now for us qk is unknown. So if I find the value such qk, or means if I make it known value, then this part is over. We convert it into generalized coordinate. So qk is equal to, what did we take? We took qk is equal to 1 to n capital N, and this will be I is equal to, and this is the qk value. So if I keep qk's value means make this solve the qk value such a way that it should be known for us, then our left part is over. Then we will go for second left, right and right part, and we will solve that equation in such a way, and we will add the both. So let us see. Now if you observe this equation, so here if you see the left hand side, this is the form of force into displacement, which show that work. So if left hand side is work, then if this should also be work. This should be work. This is the parameter of display, as it means part of displacement. So in a independent coordinate or generalized coordinate, so this will also assure it should be a work, means force. So this will call this name qk, we will call it as a generalized force, we can say. So this is generalized force. So we will solve it now and see. So if any force is if consider any conservative force. So for a conservative force, what we can say that it will be, conservative force will be equal to minus of gradient of potential. Minus of gradient of potential energies, and then this one, if I want to move further, then I can write it like this way. dou I del x ik plus y jk plus z kk ik jk kk, and there will be potential. It will be equal to del v by del x I cap and k cap. So this is the force, and this one, if I keep it here in this equation, because we are solving that generalized force equation, so Qk is equal to, we will get, it will be 1 to capital N, and it will be dou x ik plus dou v y jk plus dou v z kk, and we will get Ri Qk. Now if you see that R is a vector, and that's why I want to show in that x, y, z coordinate, then it will be x I cap, y k cap, z k cap. So this one, if I write in this equation, then you will get 1 to n and plus jk kk, and this one I can write qk, and it will be xik yjk zkk, and by solving this equation we will get, right, then minus x plus y plus, and it will be to del xi qk plus del y qk plus del z qk. This one. Now this is the function of I to I, means dot product will be there, because j is perpendicular, so of I dot j will say it will be 0. So it will mean 90-degree angle C. If you don't know, forget H is equal to 0. So these are perpendicular. So cos 90 we know 0. So this will be 0. So I will be multiply with this one. This will be get multiplied with, means j with j with k. So let me write it there, and okay. So in this equation, if we see qk, so this will be del x, and that will come del x by del qk plus not del dou y qk plus dou z dou qk. This is, and if I see, then I can write in this way, del v y qk plus del v y, sorry, qk plus del qk. This is equal to qk, and what is that? This is, if you are add, then you are thinking that if I add 1, 2, 3, this is will be 3 del v by del qk. No, this is not. This one we show that this is a part of, I did not write here I kept, because this is not showing the direction. This is directionless, because we took a dot product, and dot product we does not take. We won't take that thing, because here in between here dot product is there. So this will be x component of y component, z component. So if I add 3, then it will be whole del v by del qk. It will be like this only. You see, because this is y component, z x component, y component, z component. It came from that value answer. A magnitude if we see, because it does not have any direction, it is directionless. So this will, and now if you are thinking that how did I wrote this one, this is very easy. Means this is the, if I say any like phi is a function of x, y, z, and what is that? I am differentiating with x. There. Let me write it another way. R is the function of x square plus y square plus z square, and I want to differentiate with respect to m. But here what I know, that if I differentiate this term, this is not differentiable with m, but this is differentiate. I can differentiate it with respect to x. Means I can write it. I will write d by dx differentiate with x first, x square. Then I will differentiate x to what? dm. Similarly, if I want to differentiate, this time is not differentiable with m, but this is differentiable by y. So I can differentiate with dy, and dy I will differentiate with respect to m. Similarly, if I want to certain z, then z square by z. First I will differentiate with respect to z, then z will be differentiated with respect to m. What I am doing, same thing I did in this one. See. So actually what I am doing, actually it should be like this. If I want to show it right in another way, I can d by dm, because I am differentiating with respect to m. So it will be x square plus y square plus z square, and it should be like this. Z square dm, it should be, but I can write in this way. Similarly, this is the equation, so I can write this way. This equation I can write like this way. So both the times, if you see both the times, then you can understand. Same thing we do usually differentiating both the times. So this is it, means differentiation when we are doing, because this is dependence of, if that x is independent with respect to m, then we can't do, then it will be 0. So that is a different case, but we can convert in means like this. So this sense I made like according to that. So qk value we got now, right? Del qk, and this thing, and here qk value, and in that one we wrote like that. F was integration 1 to capital N dot del Ri is equal to and k is equal to 1 to small n, and we got qk del qk. So here if we keep the qk value back, then it will be k is equal to 1 to small n. This is the value of left hand side. This is the value of equation number 2 or 3, whatever. Let me write it, equation number 3. So this equation we got for right hand side, left hand side, and right hand side with what is that? That is p dot del r equal to. This one we will solve in next video. So this is the set. So I think now you got clear what are the things and how we are solving. So this one we will give you. Remember, this one we will use this time in next video, and we will solve further move to the equation. So these are the things. So see you in next class. If you want to move in next video directly, then after getting video ready, we will keep the link of that video in the description, so you can move directly in that video.